All right, we are finally live. Sorry for the delay, everybody. Welcome to the ReAnimators Animation Logic Hangout. We're here with a bunch of guys, all engineers from the video game industry who are very excited to talk about animation logic, debate, and maybe come up with an answer or a bunch of lies. I don't know. So let's get it started, and they're all going to do some introductions. So let's start with Alex.
Hi, I'm Alex Trumpeter. I worked on character animation when I was at Rockstar for a few years, and got bitten by animation ever since. As soon as you work in AI, that's kind of my focus. You always end up digging down into animation anyway, and I'm particularly keen on procedural animation these days. It's fun and exciting and interesting and new, and I'm looking forward to the chat.
And let's see, Bobby.
Hey, I've been I started out as an AI programmer, kind of also like Alex fallen into animation programming. I've done that at different companies before this now, and just kind of more focused on the traditional problems of kind of, integrating animation with gameplay and AI in a kind of scalable manner.
Cool. Hi, my name is Jeet. I've also been working mostly in AI and animation for the last decade or so at EA, Ubisoft, and now at Avalanche Studios. And I primarily also focus mostly on AI and player mechanics, so mainly on the gameplay side, but with a very kind of strict focus on behavior and realization. So it touches very much on animation and working with animators and how to get good high fidelity animation with good motion control for both AI and player mechanics.
And Rob's next.
Okay, hopefully you guys can hear me. I'm not hearing too well. I might try moving around after this. I'm Rob. I'm at Volition. I do animation programming. I've worked at.
I think we lost our max headroom. Why don't we go to Jeff, and then we'll see if Rob recovers here.
Sure. Hi, my name is Jeff Harrower. I'm a gameplay and animation engineer at Electronic Arts in Vancouver, currently working on EA Sports UFC, and I have a slightly different background, I guess. I've been at EA for 15 years now, holy crap, and been working on the same animation toolset for 10 years that I helped build, so I have somewhat of a sheltered life, but a lot of expertise in that one system, and looking forward to seeing what you guys have to say.
All right. I think we got Rob back, maybe? Rob, can you hear us?
A little better. Can you hear me?
All right. Yes.
All right. We'll try and make this work.
All right. So we lost part of your
intro.
intro.
Waiting on me to say something?
Yeah, we lost part of your intro. So if you want to jump back in and do that.
Sure. I'm Rob. I'm an animation programmer at Volition. I've been there for about 8 years. I've done most aspects of animation programming, from getting game side features to work to working on tools and procedural stuff. But yeah, been there for my whole game career. So that's me.
Awesome. All right. So this hangout was spurred by a Twitter conversation that was going on about current and future animation tech and tools. I know you guys obviously have a lot to say about it. So we before we started the broadcast, there was a little bit of a discussion on tools, what you guys like about tools, and the in-game implementation. So do you guys want to kind of just like start with that? I say yes. I'm going to go to Bobby, who can talk about his experience with Havok animation tools and or others.
Uh, well, when I first started with animation programming, I was first exposed to Morpheme. That was my base, apart from stuff I'd read in papers and whatever else. But my first like full-on animation toolset was Morpheme, and so I kind of took that to be, facto standard. I took that for granted. I said this is what I expect at a minimum level of a toolkit to be. And I was in for a shock when I moved to several companies, and to see that Morpheme is actually sort of like a gold standard, and the reality of animation tooling is significantly worse than what was available even in one of the first versions of Morpheme. In terms of features, in terms of tooling, in terms of iteration times, in terms of prototyping, debugging, all this kind of stuff. So I was very spoiled on my first company, and now I've been struggling to kind of get tooling at every company I've been to get back to that level. So I haven't even gotten a chance to sort of move past that. I'm just trying to get back to where I was in terms of basic tools that I have at my disposal. It seems that animation's sort of been kind of left on the sideline a little, whereas other areas have potentially gotten a lot more investment in terms of tech, resource pipelines, build pipelines, renderers, scripting systems, whatever else. But we've sort of been a little stepchild in the corner. So fundamentally, like, I prefer having animation completely outside of game code. Like, I don't want any kind of hooks. I don't want game code to be actually driving the graphs, actually switching animation states, this kind of thing. I want that all out into data. And maybe that's just my preference, but all of the code-based systems I've seen for the state switching, everything, it's just a poor man's approach to having a graph structure in data. With the added complexity of now your game code is mixing the animation transitions as well as the gameplay transitions. And it becomes kind of a nightmare trying to judge, well, I'm doing one gameplay switch, this means 3 animation switches, so on my side of my gameplay transition, I need to now wait for animation transitions to fire. It becomes a giant mess. And so I'm kind of a big proponent of treating animation as a big skin on top of the game code, and having it completely outside of the game systems and outside of the AI. And that's it. I think this should be a huge investment in tooling, both for, it doesn't need to be used by animators. This is the one misunderstanding that I always come into, is like, if you build tools, everybody's like, oh, you're building tools for animators. No, I'm building tools for myself. I'm building tools for the gameplay programmers. Like, these graphs aren't just animators that are going to be using it. Most of the time, it should be gameplay programmers sitting with an animator. And this is something that I think we need to kind of nip in the bud, is this concept that if we build tools, we offload all the work, and then we don't touch it again. That's not true. And I think that's it from my side.
Cool.
Alex is smiling.
Yes, Alex is smiling. He wants to say something.
Yeah, I mean, there's like 10 things I could have interrupted with, but I think Bobby and I have already had this conversation. Maybe we should let someone else jump in. Jeet also had a comment, I think, somewhere in there.
Yeah.
I mean, I can jump in real quick. So, I mean, to a certain degree, I definitely agree, right? I think all of us, maybe I shouldn't say all of us, but most of us will agree that we all believe in the separation of powers. Like, we believe in layering. We believe in the fact that we don't want to inject too much game code, or any game code, if anything, into the animation set or in the animation systems for ease of debugging, for making sure that if there's a bug, we can track it inside the animation side. I mean, we don't have to check in the game side. But one of the interesting things I find is, I mean, I've done the same stuff, right? I've played with Havoc Animation, I've played with Morpheme, I've played with Unreal Blueprints, I've played with EA's proprietary animation system for a long time on FIFA. I've played with our proprietary stuff here at Avalanche. And so having sort of more of a, not a kind of one set sort of exposure, I think what I find interesting about Morpheme is every demo or everything about the tool set is aimed at animators. And then we have this sort of idea of, you can really easily build a graph. You can put a walk cycle and then a run cycle, and then you can, put a variable, and then you can connect it, and then look, it's a nice run or a nice movement model. But that explodes so fast, right? We know this. Games are not a walk and a run and then a simple blend between the two. They're very, very complex. And I think what my whole, kind of injection into that Twitter conversation was about was that I think the visualization, this concept of animators need to visualize things, and that once we build a tool, we need to give it to the animator for them to be able to tweak all the game, the logic of which animation to pick and all that kind of stuff is not the right approach. I don't think that's where we need to go. I think exposing constructs, animation constructs, which then tie into game logic, which then tie into our other layers that we're kind of talking about, and then allowing the animator and programmer to work in one construct at a time. So when I say a construct, I mean like, a blend array could be a construct where you have 5 animations and you have, you're kind of blending between all of them or between a few of them based on that, space in the array you might be. That's a construct, and that needs to be visualized and be able to show, to an animator. But we don't really need the whole thing to be exposed in a graph, nor do we need controls like, a look at node, which then has to put, you need to put into this. I think some of that stuff, the things of when a look at should be applied, when IK should be applied, when should we do motion extraction, that stuff is a very state-driven thing. And for me, I believe that needs to be moved to the state side. And that's kind of the approach I've taken, which is state machines and the states that you're in, which then point to animation constructs, define data-driven code like tasks. You can add data tasks or data components that run code that then define logic within that state. But it's a very state-defined thing. So if in this state I don't want look at, I remove the look at task. If in this state I don't want IK, then I remove the IK running task. But the animation and the construct allowing the animators to be able to preview that with the variable and be able to tweak that and is separate from that. And then you can kind of blend constructs together to decide transition timings and things like that. But trying to visualize everything in an animation graph, especially with animation runtime things like IK and lookats and procedural stuff and extraction and the kind of stuff that really needs to be done on a very per context and per specific situation, which is what I find is when you're going into like really micro realization and micro control of things, you need to work with code and you need to not have to deal with sort of this kind of visualization approach, which is what I was turned off from with some of these kinds of tool sets.
Yeah, I had a very similar learning recently on my last 2 projects. We kind of got this new expression system, which is like your the kind of stuff that you guys are talking about, box and line-based expression graphs, where an animator can express any kind of logic that they want. And we actually delegated a lot of the logic authoring to an animator. And I was impressed with what they were able to do in terms of getting some functionality and some pretty complex logic working. But when you let someone who doesn't have an engineering background build complex systems like that, you run into all the problems that you would expect, which is it doesn't scale well. Complex problems are handled potentially in a poor way, and they become very difficult to debug later. I think when we start to expose visual programming languages and stuff to people who don't have an engineering background, it can lead to a lot of problems. And I think figuring out that divide is not always easy, but I think it's very important. And I'm kind of starting to gravitate back towards what Jeet just said, which is giving the animators, or a better way of saying it, people without a strong engineering background, a very well-defined box within which to define their data or logic or whatever, but they can't go outside that box. So you're kind of controlling those boundaries and architecting the system within which they are working, and not allowing them to build something sprawling and overly complex without that engineering background.
Can I jump in there for a sec?
Mm-hmm.
So I get the argument, and I've had this multiple times, but I've come in on 2 productions now at the back end of the production on an existing code base that's taken this approach, and I've seen the results of a lot of these hacks. For example, somebody's done a data optimization pass, and he said, well, I need to now do a layer of finger poses on the entire weapon handling set. And so either they've added another gameplay layer that's called weapon handling, or they've shoved it into an existing gameplay layer where it doesn't belong, or they've done something horrible like add a blend node to every single weapon handling state inside of the data, which none of those approaches work. Whereas you could simply have just, copy pasted a state and put a blend node on top of that in the graph and not change any of your game code.
Yeah, but then in that exact example, you're going to have a situation where now you don't want that layer in 4 states, or in 4 small situations when you don't want that. But then you also want it in these situations. But then you might want only 5 poses opposed. That's where I think the problem also exists in this. Like, I definitely don't want this to turn into the, programmers don't ever do bad shit, because yes, programmers do a lot of bad shit. We know this. So I don't think it's an animator's fault, or as much as it's a person that lacks an engineering experience. That definitely is part of it. But I think the tool set is the problem there. If you allow anybody, an animator or a programmer, to build complex things without being able to control the things that they need to control, or know how to easily do that, then people are going to do bad shit. Like, if it was easy for me to not say, oh, I want this face pose layer for only these states but not these, then I wouldn't just add a global face pose layer or a hand pose layer, or I wouldn't, unoptimize it, or I wouldn't do it. So I think that's again where that middle layer is really important. And I think I don't know, I haven't come up with anything better than putting it into the state side, where I know which states need this hand pose. I know I can easily add a task that will add a dynamic animation layer for those states. And so I'll just tag the state with, this task, this component that will add a dynamic layer for my hand poses. I'll define which construct to go to in that. And then if I don't need it for the X other states, I'll remove it from those states. And then kind of, that's what I mean. Like, I think anybody is going to do bad stuff with a tool or a methodology that doesn't scale well, like a graph, because it gets so complex. And I think I'm not convinced that is, or I think we can do better with that. Which you need either micrographs, or you need some kind of stuff that I don't know, a better word for construct.
But that's the thing, is that Morpheum offers some, or at least the hierarchical graph approach offers these in terms of child graphs and these kind of things. So that stuff does exist.
But it's the control that you lose then, right? It's the how do you then say I want this but I don't want this in the graph? How do you then say I want when really we go back to saying that animation is really about just playing animation with weights and then building a pose, taking a pose and running other stuff on that pose, and then taking that pose and then running other stuff on that pose. And I want to constantly dynamically change that. At least that's what I expect in an advanced animation system. I want to be able to say, half the time I don't want you to run 5 of these layers, and then some of the time I want you to run 2 of these layers. Some of the time I want you to do things additively. Some of the time I want you to do things completely, full body. Sometimes only half the pose. And we want to be able to control these things.
But that's exactly what you do with the state machines, right? That is exactly, you build a state and you put whatever layers you want inside of the state. Now, just let's say we forget animators. We completely take animators out of the discussion and just say only programmers are going to use these graphs. They're a programmer toolbox. They're not for anything else. The problem I've seen is that if I want to do a quick prototype, I don't want to change code. I don't want to have to do a new build. I don't want to have to recompile, relink, deploy on a console. I just want to change some data and hit go. And what you're saying, all of those tools exist within the states and the hierarchical states. If I want to say, I want to try to layer something on a whole subset of things, I can take that, put it in a state machine at the low level, and put a blend node at a high state machine level without any kind of real risk there. There's no code being changed, there's no danger. If I want to swap out an entire graph, I can do that, without the gameplay code ever changing. I feel like game code and the AI should just be sending intentions, saying move with some orientation, with some velocity, in some stance, and how the animation realizes that should be completely, outside of the gameplay's, whether the, what's the word, oversight. It should be completely an animation decision. If I want transition animations, if I want multiple state transitions for something. For example, a lot of people will build a basic locomotion set and say that's good. You get to the polish pass and they're like, well, let's add some transition animation, let's add some starts, let's add some stops. And that costs the programmer time. And then you always have these discussions, well, I have to spare a programmer for X days. Is that worth the cost, or should I be fixing bugs? Should I be realizing animation? Should it be fixing bugs? Should it be doing this kind of thing? And
I mean, I've seen a project using Morpheme where the programmer, like you said, right? Maybe the problem is the tool, but I definitely think the kind of high fidelity locomotion requires very, very specific control. Like you need to build it with, a good example is this. Let's take a plant and turn. And inside one plant and turn, which is an animation where you're gonna plant and move in another direction, but you've already been moving. So you're already moving during the plant and turn. Now the input that we need to understand during the plant and turn is very, very different from the input that you need to understand for a start, which is when you started without any motion, which is very, very different from the input that you need to understand from a stop, which is very, very different from the input you need to understand from if you were just constantly running, or you just want to either decelerate or accelerate. And so I would, create input tasks that are completely different, that are only running in these different states. So when I'm in a plant and turn, the input task I run is very different from the input task I would run from a start, which is very different from the input task I would run from a stop. And when you start doing this kind of stuff, the fidelity you get is significantly higher than if you were to just create at a prototype stage. I'm completely fine with you guys, creating a crazy graph of let's just add some starts and some stops and some transitions and whatnot. But I think you end up losing, one, the complexity goes up the wazoo, because when I'm debugging a plant and turn, I know which input task to go to, and I can debug that very, very easily, versus trying to debug a locomotion controller, which is massive, that has all the transitions and all the states and all the stuff, which is impossible to, in my mind, is very hard to understand. And while we say we don't want programmers to spend time doing that, I still have been, in the last 12 years, I still have to be on a project where the programmer hasn't had to get in at that level in the game to debug something in the graph because it's gotten too complex. So it's kind of like at the end of the day, you're still going to do it if it was all exposed and all graphed up and whatnot. So, I mean, that's been my experience. I could be wrong.
So I'd just like to jump in here. I'm wondering to what extent this is entirely an engineering question, because the results look the same, and over the past few years, the games have got significantly better in terms of their animation. I think the results look amazing. I think the only thing we're really focusing on is how to build it such that it's maintainable, it saves us crunch time, and so on. So I think it's this standard engineering debate whether you should layer things nicely and have very clean interfaces, or whether you handle special cases by just saying, well, doesn't matter, we're going to hack it anyway, so let's hack it up front. So, I mean, I think there's probably a middle ground somewhere between the two, and I like very clean interfaces for AI, but for player control, it ends up being very messy if you do have a nice interface. But yeah, so that was, I think, my perspective on that engineering side of things.
So I can jump in and from the animation side, I know that I like tools that let me at least previs or get a prototype done to show an engineer. So even if I'm using our tools and I'm using them completely wrong, which I do a lot, and it's fine because I rarely check it in, have them come over, look at what I did, say this is what I want to do, this is the spider web that I created, it's up to you to fix it, and then just kind of work through it with them. I think part of the reason that animation is looking better in games now is because animation teams are able to do that. They're able to go and say, I am able, instead of just spending all my time in Maya to animate this mock-up that uses everything that Maya has but our game engine doesn't necessarily have, we're able to put stuff in our engine and kind of hack it together in a prototype and then say, look, we can do it, now we just need to do it smarter. So I think that's where we're going, but I think like Bobby said, we're way behind the curve of every other visual part of game visuals now.
Well, doesn't everyone except graphics think they're behind? I mean, AI is always behind and animation's behind.
Yes, but animation is the best.
Well, but I think animation has got really significantly better, like noticeably so,
Really?
just in the past few years. No, really, like,
I
okay,
haven't
maybe
seen
not
that.
a couple of years, but like, let's say 5 years, definitely, visibly so. Whereas with AI, you still have the big debates on Reddit of people are saying, oh, this game from 2004, it's the best AI, and, you know, partly nostalgia, but there's an argument that's happening there. Whereas with animation, that debate doesn't happen anymore. It's
Well,
significantly better.
I mean, yeah, I think it's just because there's more animation. You know, that's it. I don't think that it's better. I just think there's more because we can do more.
So, sure, we have more data, but I also think that, let's say, there's always a full spectrum of the entire industry. Like, there's those that are just throwing together lots of data and just coping however best they can. And then at the other side of the scale, you have more experienced animation programmers who can put things together in a way that saves them a bit of time and that allows them to scale up. And I think this is part of the conclusion that Bobby and I came to a few weeks ago when we had a chat, was that it's partly an education problem, just like in AI. We had this is why state machines don't work so well, this is why scripts don't work so well. You move on with the behavior trees, then that solves a lot of your problems. I think that same education now is happening in animation as well, where, you know, if we were using all the ideal techniques that we're talking about today, like, what open problems are left, I think.
That's a key point, though, and this is one thing that I've met a lot of programmers, like Jeet said, that they worked with the graph and they said it blows up, complexities through the roof, it gets crazy, it's unmanageable, and that's true. But remember when you were first starting to program and you had to build a big system the first time around, you had no idea what you were doing. You built a giant fucking mess that grew out of control and you couldn't handle, right? And then a couple of years later, you look back and you said, like, what the fuck? I could simplify this. I don't have to do this. I need to be more strict here. This is the thing that we need to come to with visual languages, that we're still, I hate to say this, but we're still in our infancy of using them. They haven't really like propagated through the industry as much as they, in my opinion, should have. So whenever we use them, we tend to misuse them. We still don't have the experience in saying this is a bad approach. And this is something we learned on Absolution. We made a lot of mistakes with morphine. We made a lot. We built these monster graphs. On the second iteration, I could take down the locomotion to like 12 nodes, because we realized you can't do it this way. This is a bad approach. This layering was wrong. We need to now invert how we structure our state machines. It's stuff that gameplay programmers do, almost naturally without even thinking about it, but they forget that they're doing it. They forget that, oh, we have to refactor the state machine quickly to change the layering order. Oh, I have to refactor this code here. It's the same with the graph, and people forget that. They think you build the graph and you're done. That's not true. You need to keep going back and forth, and we need to learn how to treat visual languages like code, and we're missing that. I think that's the key point.
Yeah, I think that's actually an interesting thing that we've had experience with as we try to get more and more people involved in building the graphs, is they build it and then they don't want to change aspects of it, as that, they're like, well, it's there, it was so much work to get that working, and they're not necessarily thinking about, well, you've done it once, you know how that works. Building it a second time in a better fashion is not going to take you as long, and that's something that we, or at least on the programming side, have to do all the time. Yeah, haven't interjected too much so far because I don't, with the exception of having actually evaluated Morpheme and Havoc briefly a few years ago, we've worked entirely with in-house tools, so I'm just trying to get my head around everyone's terminology. But I feel like at Volition we've been swinging on the pendulum of what you're talking about here, of like trying to let animators go, here, you have a graph, go build some stuff, and when they come back and we're like, yeah, that's not going to cut it, let's fix it up, and we've sort of, where we are now, we've sort of interjected this scripting state machine layer in between game code and the inputs to the graph to sort of get that kind of state-based stuff that Jeet was talking about, while still maintaining the ability to look at the whole graph within the animation tools and to preview and test things either in isolation or altogether.
Yeah, I have to agree that even in my approaches, I still have a state in between gameplay and animation that actually does decision making, like when to trigger transitions, waiting for stuff, turning parts of the graph on and off. I still have that code control, like Jeet was saying, for maybe the input tasks or whatever else. I just tend to have it very lightweight and delegate a lot of the heavy lifting to the graph. But I think that we can't get away from that little state control, like Rob's saying and Jeet saying. I think that that's not going away anytime soon. And I think that is the right thing to do, is to have this in-between state-based layer. I call them animation programs or behaviors. I guess Jeet calls them, I don't know, what is your terminology for it?
Your microphone is muted.
Yep, sorry, rookie mistake. I call them state tasks, or so the states can run little component tasks that then control the graph or the animation system. But then on animation constructs themselves can run anim tasks as well, that do some of the stuff that I think what you talk about, Bobby, which is kind of offloading a lot of the selection or offloading a lot of the kind of animation-based stuff, which the data can only exist on the animation side. And so on that front, we need to kind of always have that feedback loop between animation and game, and going back and forth and constantly adjusting what you can and cannot do. But I think
maybe we're talking about the same stuff, because I could call my graph an animation construct, and maybe we've got the same architecture.
But I think what the difference is, I think, at least when I've kind of reading as well, like the stuff that you've written about animation graphs and you've presented about animation graphs. I think the difference that I have is I don't like having the weight of the animation graph, and that's, I think, just the slight difference, where I don't think things like an IK node and a lookat node and like all of that stuff should be all in one massive thing. I think it needs to be very dynamic, and it needs to. And slightly going back to what Tim said, I think the whole live preview of stuff is the sort of the biggest use case of the graphs, where you build this massive thing so that you can quickly prototype and quickly preview and quickly understand what you can use, and show someone visually in game what they want or what you want. And that goes both ways, for programmers and for animators. Like, we have programmers that do that stuff, and we have animators that do that stuff. But I just think it's more of like the responsibility. I think I put a lot more of the responsibility of game side stuff at that state machine state layer, and it's only because I think that's when it's most relevant. Like, the states know that the best. They know what they want and what they want to control and how they want to control it. And I like that micro level control. I like being able to change the way something is going to work in all these different situations, because I think for that fidelity, for that improvement in animation, you need that, I think, versus kind of the one thing that is like, if you didn't have an animation programmer or you didn't have that kind of investment at your company, then you could get this kind of one fits all kind of solution where you build everything in this one thing and then you go away. But having very, very different animation constructs for different things is kind of what I like.
So to support things like AI with your graph, would you have to rip out certain tasks that are player specific and then replace those with AI stuff, or would you have a separate graph for that?
I mean, you could have, so since you would have a completely different state layer or state machine for your AI, they could call completely different tasks, or depending again on what the animation constructs have. Like, you're free to build whatever animation constructs, subconstructs you want for the AI, and run, like, we have fairly more complex constructs for the player than we would for the AI. And so the logic needs to be different. That doesn't mean you can't share code. That doesn't mean you can't move stuff into, refactor stuff that is common. But it's just snippets of code at the end of the day. It's just in a, made in a more manageable manner, and in a more like context-oriented manner. It's like, when you need it, you call it. When you don't need it, you don't even load it. That kind of, I guess, architecture.
How do you keep state changes consistent with that approach? For example, let's say I have IK in one state, controlling the feet, and then I'm transitioning to another state that's slightly different, but I also have foot IK. Would you evaluate each state's poses completely with two IK passes? and then blend, or would you somehow try to, I don't know, blend the effectors across the transition or something along those lines? How would you deal with that consistency across these states that maybe have very similar requirements but with different end targets?
I mean, I think it again goes back to, when we talked about blend trees and having graphs at that lowest level. That's completely fine. And I think I don't think there's any other way of going about it. Like if you need to blend two different poses that have been evaluated with different data, you're going to need to keep that in a blend tree or in a blend kind of construct, and that's more on the animation side. Like that fundamental area you talk about, I think in your first part one of the thing that you and Alex talked about, which is it's just a state with, it's just a node with animation and weights. That's all it is. And then you have blend nodes on top of that and things on top of that. So in that sort of concept, you would run a state machine with that state with different tasks which are pushing different values in. But at the end, when it blends, it is having one kind of very similar node with another very similar node, and then you have a blend on top of that, and you're kind of going from one to the other at the most fundamental level. I think that doesn't change, and I think that's important to keep that. But that, I would think, that's like your lowest level animation runtime, which not a lot of gameplay programmers need to care about.
Yeah, but I mean specifically, let's say IK. I've got a very specific example. Imagine you're on very uneven terrain, and you're in one state where you've got a foot on top of a box or something, and you're doing an IK pass to keep that foot. And now you're blending to a pose that's a little bit off to the side, but it's a different state, and you also have foot IK at that point, which is on the ground. So in one pose you have the foot here, and the other one you have here. Now, if you naively had the IK as an upper layer above everything else, and you were trying to solve the physics penetration, potentially, you were kind of trying to always continuously solve. As you moved the blend, you potentially would end up doing this based on the terrain with the character. So as you were blending, you'd get blend artifacts between if the poses were quite different. Imagine a network game or something like that. Whereas if you evaluated the IK separately in the states, you'll be blending between the IK end results, which would give you a standard animation blend. So there might be interpenetration with the ground, but it'll be a smooth blend. And these are the questions. It's like, what do you do in that case? Do you have an IK layer? There we go.
Yeah, I've recently become a big fan of sticking whatever. Let's say you have a global IK system, and for whatever reason you don't want to run an IK solve on every node. I've become a big fan of sticking the inputs to that global system in the pose itself, and finding a way to construct things so that if those inputs blend with good behavior, and then the global system gets to run once on the end result. It's not just IK. Like there's some kind of higher level animation controls that we built that run on a similar system, and sometimes it's tricky to find a way to define the data so that it does blend with good behavior, but it gives you good control over the behavior. It doesn't necessarily have to be the same as blending effectors if you can stick more metadata in there to control some of the properties of the blend. And then it just works across your entire system. You don't have to worry about performance and optimization problems for running IK solves multiple times, stuff like that.
Yeah, I mean, you can have good push and pull method, like, well, not push and pull is probably not the right word, but like an on-enter and on-exit functionality too, right? So when you are leaving this and when you are going to that, you can kind of manage kind of what Jeff is saying, like the inputs or the behavior itself, to then let the animation do kind of less work in a way, because you're doing that work up front in the gameplay side or on the behavior side or state side. That's interesting. I mean, we haven't encountered that maybe because we are managing the blends, the inputs with more detail or with more control.
Yeah, I've just had to deal with a lot of network stuff where, everybody's always telling me, what if this lag? What if this lag? What if I have to pop the guide? How do we make that look decent? And sometimes the lag only will move the guy like 10, 15 centimeters, but that might be enough to change the pose completely based on uneven terrain. And you obviously don't want to pop, it looks a little bit crappy if the guy's getting packet loss or whatever. To have this
but I mean, if you're pushing all your inputs, or if you're trying to sync the input data and then just reevaluate on your own side, like your client side, you reevaluate everything, So wouldn't you be kind of evaluating your most up-to-date information to then kind of rebuild your pose?
You would, but you're potentially also replicating the position of the character, which might mean that your IK results are different, especially on like terrain. I mean, we've even seen in single-player games where a character's doing the little can move because it can't resolve to the IK position on the ground or whatever. And it's these kind of problems where it's like, I don't know what the right approach is. I'd like to actually see what you guys think. And actually, Jeff said something very interesting, is this metadata approach. Have you noticed any visual difference between, let's say, blending an effector versus blending the results of the IK passes?
Oh, absolutely. The most basic example would be, let's say you have a foot, and you got the foot IK forward as far as it can go, and you've got the foot IK backwards as far as it can go. If you do a blend between IK targets, you're going to get a linear, just a straight line between the 2 points, whereas if you're blending the end result, you'll get an arc swinging down because all the local joints are sort of, you're blending the local versus the global. So that's the most obvious example, right? But when you're getting into higher level metadata stuff, that's some of the problems you have to solve, is what kind of blend artifacts do you get? Sometimes the results are actually better that way. If you think about a guy running on a flat plane, if you do local blending of the feet could potentially go under the ground during some blends, but if you're doing blending at the effector level, you're guaranteed that they're never going to go below the ground if the data was authored that way. But at the same time, if you blend two poses that are very, very different, an extreme blend, you could get some very, very weird results as well. Imagine an animation that's facing forward, blending with an animation that's facing 180 degrees. All the joints, if they were blended in IK space, are just going to do really crazy stuff. But if your blends aren't extreme, you can sometimes get a better quality blend out of that approach as well. It gets weirder the more higher level the metadata gets, but that's part of the challenge of figuring out how to deconstruct your metadata into a sort of blend-friendly space.
Can you give us more examples of metadata? Like what?
Yeah, let's see. Well, let's say you were doing like a head tracking system. It's kind of the same as an IK target, but the look target could be in the pose itself. You could have like let's say the previous angle that you were at could be potentially a blend to manage the swing around the backside, like even just a sign or something. Our foot planting data, you're probably familiar with that, Jeet, from being at EA, that I probably shouldn't talk about too detailed, but
Yep.
all that data was calculated and injected in the pose at the lowest possible level, blended up the tree, and then the threshold stuff was determined at the very top level, and then IK applied at the end. I don't know if you guys heard my GDC talk, but the relative IK system that we built, all those constraints are injected in the pose at the lowest level and blended up to the top level, and then the final IK resolve and posing is done once at the top. But that was a challenge. That was a really, really big challenge, trying to figure out the right way to put all that metadata in, because you've got, I want my right hand to be relative to my opponent's left leg, and then I want to transition to my right hand being relative to my own hip or something like that. So you have to manage that transition from one space to another inside the metadata, and it's tricky, really tricky to do, but it works really well, and like we're trying to move our IK system into our physics system. I mentioned that in the talk as well, and we just can't afford to run physics multiple times on characters, so we have to find a way to move all this metadata into the pose so that it can be resolved once.
I think this ties in very well to what Bungie's doing with their runtime rigs, and they had also a talk at GDC where they were showing their Python extensions for Maya, where they could specify the blend space for each of the IK effectors, local space relative to the object, relative to the pedestal or whatever you call it. So it seems like this is a general direction that people are going in, and this is something I don't know as much about, so I'm very curious to hear that. Do most of you use IK once and only once, and it's always enabled, or do you have certain cases where for characters that are in the distance, you just get rid of it completely?
We turn it off depending on the context sometimes too, because the IK result just isn't appropriate for the current state that the characters are in. So we'll enable and disable it on different joints, different chains, different complete approaches will be enabled and disabled depending on the state.
Yeah, we're still pretty, but like getting all that stuff to work is what I've been dealing with for the past, I don't know, year or so. And yeah, we definitely can't afford to be doing it multiple times for multiple characters, so we tend to just have, yeah, it all has to feed into once, and we do some or we'll be disabling it at distances or not involving physics if it's run at certain distances.
Yeah, so it seems like Destiny has a nice special case where they can afford to have that on. They don't have too many enemies, and they can. At least my understanding was they were doing that at runtime. Bobby disagreed a bit with me last time we talked about it. They were just doing a lot of this stuff, IK-based things at cool side. But I think they're doing it at runtime. I looked into it a bit more, but I'm not sure about that.
Well, I mean, I would think that they would not. I mean, if you can't, if the character is too far away, it doesn't make sense to keep it on, right? I guess it seems weird that it would always be on.
Well, but that was their core. Like that was the fundamental approach that they took. They said, okay, let's rethink all the animation and let's do it in rig space as opposed to just a low-level bone space. And so if you do that and you export all your animations in rig space, you have no choice. But to do that, you need to have your IKs, well, whatever, like 2-bone IK most of the time, solving each of those because the data's just not there unless they're exporting all the low-level data and they're just using this rig space concept inside their client pipeline.
Here's another argument for that type of approach would be, imagine you had some logic that needed to maintain state that depended on a joint position or something like that, and then if the guy's going too far away and you want to turn off the actual IK solve and then turn it back on again in a few frames, that state information is lost and you're completely reset. But if you can figure out a way to get that state information that's dependent on a joint position to still be able to evaluate in a very cheap way, you can keep that logic running as they pop in and out of whatever that threshold is, and you don't get that complete state reset as things go away. I don't have a concrete example of that, just something I was thinking about with some of our solutions that would probably break if you had like an LOD system like that.
Maybe this ties into that. My approach for building an animation graph, at least, is that the graph itself just registers animation tasks. In my case, since all IK and pose modification is in the graph, all I do is I register like a sample task, then a blend task, then a pose modification task, then an IK task outside of the graph. So the graph always runs, always maintains state, but it's up to me at a second stage to determine whether I run ragdolls, whether I run IK, whether I run lookats. And then I can set up LOD rules for that completely outside of the graph, where animators don't care, nobody cares about that. Right. And then I can do that. So I have the state. So as soon as I need to turn it back on based on frustum or whatever culling, I can just re-enable IK from one frame to the next and have it completely consistent.
Right. The kind of thing I'm thinking about is like foot planting, for example. If you were to like detect when the foot becomes planted and lock it in place, if you actually have to evaluate the pose in order to figure out where the foot should be, then the answer to that question will be different. Whether if you're running the full pose versus a limited amount of pose or no pose at all. But yeah, I think what you're describing makes a lot of sense. Oh, I just thought of another piece of metadata, Jeet, if you're interested. I'm sure other people have done this a lot as well, but like if you're playing a turn animation and you want it to dynamically steer towards its target, stick the end face angle of the animation as metadata and then steer the end face angle as opposed to the current face angle, that type of stuff. That's the kind of metadata I'm thinking about. Same with like aligning characters, stick the scene origin. If you're doing like 2-player animation alignment, stick the scene origin in the pose and then you can blend the scene origin.
So it's kind of like, yeah, a lot of anchoring and that kind of stuff.
Yeah,
I'm going to ask the Holy Grail. Does anybody here have a tool for automatically marking up footstep placement, end orientations, displacements? That's something animators always ask me for, and I have to keep saying, I haven't found one that's reliable enough that
Yeah.
works.
First pass and then allow them to modify it has always been what seems to come out.
So nobody
Yeah.
has a magic toolbox for this?
Close, but never perfect.
Yeah, I mean, it's like cover generation or anything, right? I mean, you do a good first pass.
Nice. All right. Well, it looks like we're coming up on our hour, guys. So I don't know if you guys want to like have any like last words, or if you guys want to just wrap it up now.
You know,
But
I have one question, I guess, for the whole group is experiences with IK, external IK solvers and stuff like that. What are you guys doing? What are you guys looking into? Are you guys looking at, Bobby talked a lot about the iKinema stuff, which was kind of really cool when I looked at it. But are people still using internal stuff, proprietary stuff, or are we going into how many of you guys use human IK or all that kind of stuff? If people want to chime in real quickly about that.
There's one thing that you can do that's cheap and everybody can try out. Something we were experimenting with at IO was use your physics ragdoll as a solver instead of an IK solver. You have constraints there. Why not just use the physics solver as you would, like sort of like a powered ragdoll, to solve your IK instead of actually doing an IK pass?
That's what we're doing because the IK and the physics end up fighting, and there's no way we can end up fighting. And UFC is very tight, close quarters grappling, and there's just no way to enforce the constraints and still enforce the physics volumes without them being in the same solve.
Do you guys switch between the two, or do you just have one on?
We're moving towards just one on. We still have our IK system in there. We're in the process of migrating. It's been a very difficult process, but once we're there, we'll be in a really good place. But yeah, we'll be exclusively physics once we go there. We were 2-bone IK last year, 2-bone IK plus physics, but tons of like custom change iterations and stuff. But yeah, if the physics would, I think physics ran second. So IK would run first, physics would run second, and then so many of our constraints got broken. So then we started hacking in these things called physics grabs, which would add an extra physics constraint on super important joints that had to stay where they were, like hands on the ground or something like that. But it was a huge hack. So now we're just moving the whole IK system into physics wholesale and be done with it.
So yeah, I think our requirements are a lot less stringent than some of the stuff you guys are working on. But yeah, it's all at the moment it's all 2-bone stuff that's just layered together and some minor tweaks to certain bones, and all internal stuff, no external tools.
cool. All right. Well, I think we are about out of time. Sorry we started a little bit late, but I think one thing we might try next time is actually get that Q&A app up, because we had some questions come in on the ReAnimators site that I did not get us to, but I think we can probably answer those afterwards. So thank you guys all very much for joining. I think a lot of people got a lot of useful information from you guys, and I hope we can do this again.
Thanks, Tim.
Awesome.
All right.
Thanks for having us.
Thank you guys.
Bye,
And
everyone.
we'll have this link. There'll be a streamed link posted on YouTube. We'll post it on the ReAnimator site, and we will get it on Twitter and everything so everybody can see it. And I'll send it out to the group as well. All right. Thank you all.
Bye,
Thanks,
everyone.
Tim.
Bye.
Cheers.
Ciao.